Welcome you all to the new session of computer graphics. Today we will be learning about memory representation of characters. That means how characters are represented in memory. So there are two different methods used for storing characters in memory. One is Bitmap Font method and the next one is Outline Font method. So first let me teach you Bitmap Font method. So we will be learning how character is stored in memory using this method. Consider a buffer. This buffer stores the pixel intensity values for a single character. What is it? This is a buffer which stores pixel intensity values, that means ones and zeros. But it stores the pixel intensity values for a single character. Now what is the difference between this buffer and a frame buffer? Frame buffer is a temporary memory which also stores pixel intensity values but for the entire screen. So frame buffer stores the pixel intensity for the entire screen, but this buffer stores pixel intensity values for a single character. That means only one character. Okay, now let me talk about the size of this buffer. This buffer is an 8 by 8 buffer. 8 by 8 means there are 8 rows and in each row there are 8 columns. So altogether this buffer can store 64 bits. So what does this mean? To store a single character, that means to represent just a single character, 64 bits are needed. Clear? Okay. Now suppose if I want to display the character C on screen. To display this character, this is the shape of character C. Clear? This is the shape of character C. So to get the shape of the character on the screen, put a 1 on all those positions so that these positions are highlighted. So to highlight these pixels on the screen, in all these positions a 1 will be stored, and wherever nothing is to be displayed, a 0 will be stored, like this. See, all these positions are storing 1. And wherever a 1 is stored, the corresponding pixels will be highlighted on the screen. And these positions when highlighted creates the shape of the character C. And wherever nothing is to be displayed, we will store 0. So this buffer stores the pixel intensity values for a single character. Clear? Now, when some of the pixels stores 1 and the remaining positions stores 0 and the electron beam passes through the screen positions, wherever a 1 is displayed in the buffer, the corresponding pixels will be highlighted and on the screen the character C will be displayed like this. So in this way, to display a particular character on the screen, we use ones and zeros in the buffer to get the character represented in memory. So this is all about Bitmap Font. Let us move on to the second one. It is Outline Font. It is quite simple. In Outline Font we use only two primitives. One is a straight line and the second primitive is a curve. So by using curves like this, all these are different curves and these are different line sections. So by using lines and curves, character shapes are constructed. What is it? By using just straight lines and curves, we can create character shapes. See, by using just straight lines and curves, here I have tried to create the shape of character B. In the first method, we used ones and zeros to represent the shape of the character. But here we used straight lines and curves. So let us now compare these two methods. First, let me talk about the bitmap method. The bitmap method used a buffer of size 8 by 8 such that it uses 64 bits to represent a single character, which means it uses too much of space. That means if it requires 64 bits for a single character, it may require thousands and thousands of bits to represent the entire text. That means it causes wastage of memory space. Now, it is very difficult to change the character shape. That means for representing a single character, to represent a single character, we have to use so many digits arranged in a special fashion so that it can create the shape of that character. Now, to store some other character, all 64 bits have to be changed. So it is very difficult to change the character shape. To change the character shape, we have to change all the 64 bits in the buffer. Now, next is even though the bitmap method is having this much of drawbacks, it is very easy to define. We can use just zeros and ones to define a character. Now, what about the outline font? Outline font does not use any type of buffer, and therefore it does not cause any memory wastage. Now, what is it? Since it uses only straight lines and curves for representing or drawing the character shapes, it is very easy to modify the shapes of the character. Clear? So this is how two different methods can be used to store characters in memory. Let us move on to next topic, which is inside-outside test. This is a test which can be used to identify the interior or exterior points of a region. That means if this is a region, this is an interior point and this is an exterior point. Okay, so this is a simple figure. We can easily identify which is the interior point and which is the exterior point. Similarly, inside-outside test is also used to identify the interior and exterior points of a region. So there are two types of inside-outside test. The first test is called odd-even rule. Okay, and the second test is called non-zero winding number rule. Both these methods are used for finding interior and exterior points. Now first, let us look into odd-even rule. Consider this figure. It is a bit complex figure, ranging from A, B, C and D. 4 corner points are there in this region. I am going to identify whether P1 and P2, among these 2 points, which is an interior point and which is an exterior point. Okay, so to identify the interior and exterior point, the odd-even rule says put a point anywhere on the figure. Put a point anywhere on the figure. From that point, draw a straight line. What did I say? Put a point anywhere on the figure and from the point draw a straight line. Identify how many edges does the line cross. Identify how many edges of the region does the line cross. What does it mean? We have to count the number of times this line crosses the edges of the region. Let me check. This line crosses first edge AD. This is the edge AD. So this line crosses the edge AD. Next, it crosses the edge BC. This is the second edge. And the same line crosses the edge BC. Again, it crosses the edge CD. So the first point crossed 3 edges, edge AD, edge BC and edge CD. So it crossed 3 edges. So let us write point P1 crossed the regions, boundary regions 3 times. That means 3 edges are crossed by the line drawn from point P1. Now this 3 is an odd number. This 3 is an odd number. The rule says if the line drawn from a point crosses the edges odd number of times. What did I say? If the line drawn from the point crosses the edge odd number of times, then it is an interior point. So what we can say, since the line drawn from P1 crossed 3 times and 3 is an odd number, P1 is an interior point. Let us check point P2. As per the rule, from the point P2 we have to draw a straight line. After drawing a straight line, we have to examine how many times does this line crosses the edge. P2, the line drawn from P2 crosses the edge AD and crosses the edge CD. That means it crosses 2 times. The line drawn from point P2 crossed the edge boundaries 2 times, and 2 is an even number. Again the rule says if the straight line from a point crosses the boundary even number of times, then it is an exterior point. So altogether we can say when a line drawn from a point crosses the edge boundaries odd number of times, that point is an interior point, and if the line drawn from a point crosses the edge boundaries even number of times, then that point is an exterior point. So simple. So this is all about odd even rule. Let us move on to the next one, which is non-zero winding number rule. Okay, so here in this method we will be using a winding number. Forget this word winding. Clear? Just consider that we are using a variable. Okay, any number which is initialized to 0. So we are using a variable which is initialized to 0, and the name of the variable is winding number. Okay, so in non-zero winding number rule we have a variable which is initialized to 0 and name of the variable is winding number. Okay, let us see how this method works. Again we are taking the same figure A, B, C, D. This is a figure which we had seen just above in odd even rule, but here there is a difference. Along with the figure we are also considering the directions. So here we have to consider the region with the directions, but odd even rule does not consider directions, it just considers the region, whereas non-zero winding number rule considers the region with directions. Remember that point. Okay, now the same thing. What did I say? We have to consider a region with a set of directions. Now again starting from a point, put a point anywhere on the region. Clear? From that point you have to draw a straight line. So from point P1 I drew a straight line. Again observe how many times it crosses the edges. Again it crossed 3 times. It crossed 3 times. Along with the number of times we have to consider the direction of the edges also. In odd even rule we just considered the count or the number of times the edges were intersected, but here we have to consider the number of times the edges are intersected along with their directions. So why we are considering the direction? When considering an intersection, if the edge moves from left to right or if the edge moves from top to bottom, there are 2 options. If the edge moves from left to right or the edge moves from top to bottom, then we have to subtract winding number by 1. That means if initially the winding number is 0 and in the first intersection if the edge moved from left to right or from top to bottom, we have to subtract the winding number by 1. It means from the current value of winding number we have to subtract 1 from it. That means 0 minus 1 is minus 1. Clear? What is the next rule? If the direction of the edge is from right to left or from bottom to top, I will show. This is an arrow which moves from top to bottom. This also moves from top to bottom. Now what about this? This moves from bottom to top. This also moves from bottom to top. Sometimes we may have edges like this, where it moves from left to right, and this is an edge which moves from right to left. So this is how we have to consider. If the edge moves from right to left or from bottom to top, then we have to add 1 to the winding number. So there are only two rules. Initially, winding number's value is 0. Thereafter, when each time the straight line crosses an edge, consider the direction. Depending on the direction, either we have to subtract the value from the winding number or we have to add 1 to the winding number. Okay? So let us come to the example again. So first we will consider the point P1. From P1 I have drawn a straight line, and P1 intersected the edge AD. P1 intersected the edge AD. AD is an edge whose direction is from bottom to top. As per the rule, if it moves from bottom to top, we have to add 1 to the winding number. Initially, winding number's value was 0. After first intersection, since the direction of the edge is from bottom to top, its value will be incremented by 1. So the value of winding number is now 1. Again proceeding to next intersection. Second time again the straight line intersects the edge BC. This time also the edge moves from bottom to top. If edge moves from bottom to top, we have to again add 1. Okay, so the value was 1. After second intersection, we have to add 1 to the winding number. So initially it was 0. After first intersection, the value incremented to 1. After second intersection, again the value incremented by 1. So 0 plus 1 will give you 1 and 1 plus 1 will give you 2. Each time you have to consider the direction. Depending on the direction, either you have to subtract 1 or you have to add 1. In both these intersections, the direction was from bottom to top. Second intersection also from bottom to top. So after first intersection we will add 1. After second intersection also we will add 1. So from initial value 0 we came to value 2. Now again proceeding to third intersection. Third intersection we are considering the edge CD, and this time the edge moves from top to bottom. So since the edge moves from top to bottom, you have to subtract 1 from the value. So the value was initially 2. After subtracting 1 from it, you will get the value 3. So these are the 3 different intersections. The first intersection you will get the value from 0 to 1. 1 will be incremented. After second intersection again you have to increment 1, the winding number increments to 2, and then after third intersection, since the direction is from top to bottom, the winding number will be subtracted by 1. So from 2 we will be getting a value 1. So final value of point P1 is 1. The rule says if you are getting a non-zero value, the final value of winding number, if it is a non-zero value, then this will be an interior point. If you are getting a non-zero value, then it is an interior point. Okay. So P1 is an interior point. Clear? What about P2? From P2 also we have drawn a straight line. P2 intersects twice. In first intersection, the edge moves from bottom to top. So value of winding number should be incremented by 1. That means initially the winding number had a value 0. After first intersection it will be incremented by 1 and it will become 1 again. After second intersection, the edge moves from top to bottom. Since it moves from top to bottom, winding number's value will be decremented by 1. So After second intersection, the winding number's value will be decremented by 1. Finally, it became 0. It had only 2 intersections, and after 2 intersections, the final value of winding number is 0. So, if the final value of winding number is 0, it is an exterior point. So, the rule is you have to calculate the final value of winding numbers depending on the direction rules, and once the final value of winding number is calculated, if the final value is a non-zero value, it is an interior point. If the final value is a zero value, then it is an exterior point. So these are the two different methods that can be used to identify the interior and the exterior points of a region, and it is known as inside-outside test. Hope these concepts are clear to you. Thank you. Thanks for watching this video. If you liked the content of this video, then don't forget to like and share this video. Remember, if you are not yet subscribed, then subscribe my channel. Also, press the bell icon.